Why should a developer want to come build on Bitcoin?
So for me, the exciting part about being a developer in the Bitcoin ecosystem is we have the opportunity to kind of start at the very beginning and build up a new financial infrastructure, but one that's based on the same principles of transparency, openness, decentralization that Bitcoin itself is built on, which is really the ultimate promise of cryptocurrencies. It's supposed to open up the financial world to people.
Hi, everybody. Welcome to the Bitcoin Builders Show. We are here to talk about everything that is happening when it comes to building on Bitcoin. And today we're joined by our guest, Kenny Rogers, or KennyRogers.btc. Today I'm your host, Kyle Ellicott. With that said, Kenny, a short introduction on yourself.
Hey, yeah, thanks, Kyle. My name's Kenny. I'm the developer advocate at the Stacks Foundation. And so short version of that means that I basically focus on developer outreach and education. So I write a lot of tutorials, work on some documentation, help developers one-on-one, workshops, events, all that fun stuff.
Right on. Well, and Kenny, that's exactly what I want to talk about with you today. So in your role in terms of talking about developers, developer relations, take us back in time. What is your backstory of getting into development, becoming a developer, and then later migrating over to blockchain development?
Yeah, so I've been a developer for just about 10 years now. Most of that has been in just traditional front-end full-stack JavaScript development. Started teaching myself online about 10 years ago. Did that up until 3-4 years ago. Discovered Bitcoin, thought it was super interesting, liked it, and then promptly moved on and forgot about it for a year or two. And then found Ethereum and thought, oh, this is cool. I can actually build stuff on this. Kind of seems like it's the same idea as Bitcoin, but for developers, I'm going to start building on this kind of stuff. And then that was roughly 3 to 4 years ago, I think, is when that happened. And so then I started getting into Solidity, started doing a little bit of Ethereum development. The agency that I was working for at the time was getting really into Ethereum development. So I started kind of seeing where this was going, but I always had Bitcoin in the back of my mind because the more I got into the Ethereum ecosystem, not a fan of proof of stake. I always had Bitcoin as the OG currency in my mind, but it's just like, yeah, but you just can't build on it. So like I'll stick with Ethereum because that's what I can build on. So I kept building on it. And then one of my coworkers pointed out Stacks to me. And then I actually was really pulled into the Bitcoin ecosystem through Stacks because it was kind of this resurgence of, oh, wait a minute, it looks like maybe I can build on Bitcoin. So that was kind of my journey from developer and then to Web3 and Ethereum, and then kind of like circling back to Bitcoin, which is interesting because I've talked to some other developers in the Bitcoin and Stacks ecosystems, and that's actually a relatively common path is where a developer finds Bitcoin and they really like the idea of having decentralized money. But then they go, yeah, but I can't build anything, so I guess I'll just move on to Ethereum. And now in the last 6 months to a year, we've really seen this like resurgence in this attitude of building on Bitcoin. And we're seeing a lot of Ethereum developers that are now kind of coming back into the Bitcoin ecosystem now that building on it is really becoming more of a growing movement.
And what do you think is driving that movement? You mentioned about 6 to 12 months ago, we've started seeing this beginning of it. What maybe sparked that in your mind as a developer and working with so many?
From what I can tell, I think it was kind of multiple factors coming together. I think probably the big catalyst for it was definitely Ordinals. We just saw this huge resurgence and like, oh, wait a minute, people are actually building things on Bitcoin. But the interesting thing about that is that at the same time Ordinals took off, there were these other protocols on L2s, Lightning, Stacks, RSK, all these other things that were already in development. But really then Ordinals kind of kickstarted the interest in building. And then people were saying, oh, wait a minute, look at these other L2s that exist that allow us to kind of build on Bitcoin. And I think at the same time, this is maybe more of a personal take, but I've just anecdotally talked to other developers about this. This all also happened around the same time as Ethereum started moving to their proof of stake system and moving off of proof of work. And so that really just caused another divide between like the Bitcoin and the Ethereum ecosystems. And that's a relatively contentious topic, is on whether proof of work or proof of stake is a better consensus mechanism. And so you kind of had all of these factors coming together where Bitcoin seemed kind of stagnant for a while, but there were still so many Bitcoiners. People were buying and holding it. Developers originally found Web3 cryptocurrency through Bitcoin and then moved on. And then all of a sudden this renaissance just kind of kickstarted and got catalyzed. And I think the Ordinals was probably the main driver of that. But I also don't think it would have necessarily taken off the way it did without these other factors at the same time.
That's a good point. And for those who may not know and that are, again, getting started in their development journey, what is Ordinals and how does that apply to the Bitcoin layer ecosystem. So everything from the Bitcoin core network all the way up through the L2s that you're mentioning currently.
Yeah, so Ordinals originally started off with this developer, Casey Rodimer, came up with ordinal theory, which is basically just this idea that every Satoshi, which is the smallest divisible unit of Bitcoin, actually has a number assigned to it. Basically, oversimplified, the order that they're mined in, they can have these numbers assigned to them. So that's where the word ordinals come from. It's just this ordinal theory, this way of making Satoshis in a certain sense non-fungible, to where they can be distinguished from one another. Then the second piece of it, and really the one that I think has caught the most interest and taken off, is this idea of inscriptions. And this is where, because of a little bit of a quirk in one of the upgrades to Bitcoin called Taproot, you can actually inscribe arbitrary data into an individual Satoshi in what's called the witness data. So you can actually inscribe data up to the maximum block size, which is 4 megabytes, into an individual Satoshi. And so rather than being like something like an NFT where you might have metadata in like JSON format pointing to some external URL of an image. In this case, let's say the ordinal version of an NFT is you would actually be writing the image data directly to the Bitcoin blockchain. But you can do this with any like valid MIME type of data. So you can do this with text, you can do it with HTML. People have actually coded HTML sites into an inscription and then read them from the inscription. So their website is a static HTML site. So it's very basic, but it's hosted on the Bitcoin chain. And so that's basically what ordinals and inscriptions are.
Wow, pretty cool. I also saw, I believe, a mini version of Doom as well that was executable and you could play. Took you back to very, very, very far back days of video games as well. And speaking of going back, let's go all the way back to the basics, Kenny, on for the developer looking to begin their journey on Bitcoin. What are some of those basics that developers need to be aware of when entering into building on Bitcoin that might not have been relevant in either Ethereum or previous ecosystems that they might have been a part of?
Yeah, one of the difficult things about getting into Bitcoin development is it works very differently than what most developers are going to be used to. So if you come from JavaScript, PHP, Ruby, Python, Solidity, all these other languages, the way that Bitcoin works is very different. And so I think the 3 key concepts for new developers coming into Bitcoin to look into are addresses. So that might seem simple, but there's actually a lot that goes into how different types of addresses are generated. So if you can look into how addresses are generated, I think that's sort of like step 1. And then the really big, like, fundamental system that operates Bitcoin is called the UTXO system, which stands for unspent transaction output. So if you look at something like Ethereum, it works on the accounts model, which is similar to how like a bank account might work. I have my Ethereum address. I have 2 Ethereum in it. I want to send you 1 Ethereum. I'm just going to take that 1 Ethereum out of my account and put it in your account. But that's very different from how the UTXO model on Bitcoin works. And this can be a little bit difficult to wrap your head around, but I'll try to simplify it a little bit here. But basically, the way that Bitcoin works is it's just one gigantic long ledger from the history of the beginning, from the very beginning of the history of Bitcoin, that's recorded every single transaction one by one. And so when you say that I have 1 Bitcoin, what you're really saying is that the record of all Bitcoin transactions reflects the fact that all of these transactions that have been made have resulted in this end state of me having 1 Bitcoin that I am allowed to spend. And so what does allowed to spend mean? Well, that leads us to kind of the third main component of Bitcoin, which is scripting. Every UTXO, unspent transaction output, that's what actually decides how much Bitcoin you have available to spend. And how that works is that the protocol will check what's called a locking script on the Bitcoin. And this is a set of conditions that basically say, these are the only conditions under which this Bitcoin is allowed to be moved to another person. And the most common and the most basic version of that is that I have to provide the key for that with my private key that corresponds to my public key, which gets compiled down to an address. But that basically provides the unlocking script. So if I have 2 UTXOs, one that's 1 Bitcoin and one that's half a Bitcoin, my wallet balance will say I have 1.5 Bitcoin. What that actually means is that there are 2 transactions that exist in the Bitcoin ledger whose locking script I am the only one that can unlock. And I do that by combining my private and public key in this super complex mathematical cryptographic function that basically then I can pass into the Bitcoin program, the computer program. It will read that script, and it will say, okay, yes, this matches up. This transaction is allowed to be spent by the person with this private key. So then I can send you half a Bitcoin. And there are more details than that. But that's the basics of it. But that is something that is just absolutely essential for people that want to get into Bitcoin development to wrap their heads around, because everything that's built on top of Bitcoin ultimately is built on top of this UTXO model. So whether you want to be a Bitcoin L1 developer and work directly with the L1, or you want to do L2, whatever, ultimately stuff is going to be built upon that transaction model. And so understanding the fundamentals of how that works is going to be probably the most important piece of becoming a Bitcoin developer.
So addresses, UTXOs, and scripting. Those are the three basics.
Yep, and you could say that as like addresses, transactions, and scripting too. And those things are all also very tightly coupled. But like if you had to separate them into three components, that's probably how I would describe it.
Got it. And then you mentioned a few languages. I believe Rust, Solidity got thrown out there, and maybe Clarity. If not, I do want to talk about Clarity. But what are the differences between some of these languages, whether they're smart contract languages or just general programming languages, that those who, again, are entering in this space for the first time as developers, Rust, Solidity, and Clarity? What are the differences between these?
Yeah, so those are kind of, in my mind, what are the like most commonly used smart contract programming languages. And the way that I like to approach them is kind of in this like hierarchy of complexity or specificity. And what I mean by that is, let's start at the top with Rust. Rust is not a smart contract language specifically. Rust is a systems level language. And what it's really designed for is very efficient memory management. And so what that means is that Rust is really good at, if you have to write a system that needs to have good, solid uptime and isn't going to be bogged down by memory issues, that's something that you would maybe want to write in Rust. And it kind of got adopted by a couple smart contracted blockchain communities. Solana, I think, is the biggest one. I think Near also uses Rust. It got adopted by these because it is a very, very elegant, well-loved language. I think like Stack Overflow does a survey every year. I think it's the most loved language, like 2-3 years in a row now. So there were some reasons for it, but it's not a domain specific language. It's not specifically designed for smart contracts. And so a lot of this memory safety that's built in comes with a lot of complexity. And so if we're building something like smart contracts, we always have to remember what their primary use case is. And the paradigm that I like to use for this is, let's stick with the main use of like Bitcoin and cryptocurrency, which is money. If you look at all the stuff you can do with money, once it starts to get a little bit more complex, or you have to do a lot of different things with that money or a large amount of money, you usually have to bring in some sort of external third-party institution that's going to perform those actions for you, which means that you either have to give them your money and trust that they'll do the right thing with it, or vice versa. If you're the one receiving money, you have to trust that they're going to do the right thing to give you that money back. And that works both ways. So the way that I like to think about it for people just getting started out is, smart contracts are designed to replace those third-party human institutions so they can replicate that same complex functionality, but without having to trust another person who may or may not do the right thing with your money. So back to the programming languages, what does that have to do with these three different languages? When we're doing stuff like this, the risks are very high, and we want to make sure that the language that we're working with has as small of an attack surface as possible. And so when you use a complex systems language like Rust that is designed to do all kinds of different things, you unnecessarily open up these different attack vectors and these different avenues of complexity when you're not actually getting any additional functionality from that in a smart contract, because it's just not what it's meant to do. But what Rust is really good for is for writing long-running programs that need to have very efficient memory usage, like a blockchain. So the Stacks blockchain itself is an example of the blockchain code is written in Rust. There are plenty of systems levels things that are written in Rust. I believe Solana validators are written in Rust. So those types of systems are good for Rust, but I would argue that it's too complex for smart contracts. So then you go one level down to Solidity. Well, Solidity is a smart contract specific language. That's what it was created for. But it's still, in my opinion, a little bit too complex for this use case. And we see hacks in Solidity all the time. Not all of these are going to be solved by just like language features, but a lot of them can be. If we look at complex language functions that exist in Turing complete languages like Solidity, like you have things like for loops, you have things like reentrancy attacks, and all of these are really complexity issues, because the more features and the more complexity you add, the more of an attack surface you have. That's just the way that it's going to work. And so sweet spot for a smart contract language is how do we build a language that has enough features to do everything that we need to do, but no more, so that we can hit this stopping point where we can say we can do everything we need to do with a smart contract, but we don't have all of this unnecessary complexity coming in. One example, so we'll get into the Clarity versus Solidity comparison, is Solidity is much more similar to what traditional developers might be used to with like an object-oriented language. So you can pull in libraries. There's a lot of functionality abstracted behind the scenes, and that's a double-edged sword because it means that there's a lot of things that can be done in relatively few lines of code where the developer's not having to manually implement certain functionality. They can inherit it from an external library or something. But when we're talking about smart contracts, sometimes I have a hard time describing the main benefit of Clarity without sounding cheesy, because I just think it's kind of in the name. Like, is the main benefit of it is that it's just very clear exactly what it's doing. So you compare something like Solidity to now, let's move into like Clarity. So Clarity, now we're one level down in this sort of like hierarchy of complexity that we have, where Solidity is smart contract specific. Now Clarity is specifically designed to write safe, secure smart contracts. So it's taken a lot of the lessons learned from the 8 to 10 years, I think, that Solidity has been in existence. And it's saying, okay, where do a lot of these hacks come from? What is this complexity that we're seeing in Solidity, and is all of it necessary? And then it basically tries to find that balance between let's have all the functionality we need without the additional complexity. So a couple ways that manifests itself are it's non-Turing complete, which oversimplified version just means it doesn't have unbounded loops. So you can't have a perpetually running loop in Clarity. You actually can't have a loop technically at all. What you can do is you can iterate over a predefined set of data, but you can't loop over an arbitrary amount of data. And you also can't inherit logic from other libraries. It's not object-oriented. You have to manually write everything you want your smart contract to do is going to be there exactly line by line. And if that fails at any point, it's just going to bail. And so this avoids another problem that we see in Solidity, which is called reentrancy. Short version of that means call into a contract, but before the contract has updated the data state, you can call into the contract again. So an oversimplified example of what this might mean is that let's say that I'm transferring something from myself to somebody else, and then I need to update my balance of whatever I'm transferring. What a reentrancy attack might allow you to do is to transfer to that person 10 times before the balance gets updated. And then so that makes it so that you're sending way more than you meant to in the first place. And that is an anti-pattern that's kind of brought about by this complexity that's just not allowed in Clarity at all, because it, again, tries to find that balance between doing everything we need to do, but in the clearest way possible that's not going to add additional attack vectors.
And with that said, Kenny, let's kind of look at maybe the reasons why a developer would want to come develop on Bitcoin versus some of the other networks today. I mean, you mentioned Ethereum was where part of your journey began. We have tons of Ethereum virtual machines or EVMs and other networks as well, and other L2s within the Bitcoin network. But why should a developer want to come build on Bitcoin?
I think there's a few main reasons. The first one is kind of connected to this complexity issue that we talked about, so I'll start there. But Bitcoin is very intentionally designed to be as simple as possible. And as we started seeing these new blockchains emerge that would add complexity, they would add speed, we would kind of start to hear that that's a negative, that Bitcoin's old, it's too slow, we're moving on to more modern blockchains. But the Bitcoin community never sort of like fell into that trap of like, let's just keep growing and keep getting faster and keep getting more complex. It stayed simple. And so what that means is that, again, just like the smart contract language, the attack surface for Bitcoin is very, very small. Whereas if you look at something like Ethereum, which has way more complexity built in at the base layer, it's just this massive, massive code base that I would be willing to bet that there are very few people, if any, in the entire world that actually know how Ethereum works from like beginning to end. There's a company called Foundry, and they recently took on the seemingly impossible task of making a new Ethereum client. And the founder posted on Twitter that Ethereum is a behemoth of unknowns. And they just realized as they were digging into this that there's just so much to this code base. Part of that is complexity. Part of that is because proof of stake is a significantly more complex consensus mechanism and requires all kinds of different little loopholes and workarounds to try and work through some of these vulnerabilities. But reason number one is this layered approach. Bitcoin stays very, very simple. It stays the safest, most secure base layer that doesn't really change much at all. But then we add in complexity and we add in speed and layers so that if something were to be compromised in one of these more complex layers, the base layer itself is not compromised. And then we can sort of add layers based on what they specialize in. So Bitcoin can specialize in being the simple, secure, safe, stable money. L2s like Stacks can specialize in adding functionality and specialize in smart contracts and how to do that properly. And then maybe other layers like Lightning can come in and specialize in speed and scalability and making sure that we can scale this thing up so that people can make basic one-off payments for small things like coffee, which is just not feasible to do on L1 right now. So that's reason number one, is I really like this idea of building of this layered concept of let's keep each layer sort of separate in what it specializes in and keep Bitcoin at the bottom as the simplest, safest, most secure part of it. So the worst case scenario, if these other layers on top of it fail or don't work, we still have Bitcoin there chugging along and we can reevaluate what layers we're going to kind of put on top of it as we go. But that's reason number one. And then reason number two is because there's this weird inverse relationship where Bitcoin's the oldest cryptocurrency, but also has like the most stable history, but also the least functionality. We've sort of seen this weird inverse market relationship where Bitcoin's market cap is roughly double Ethereum's, but its app ecosystem is almost non-existent compared to Ethereum's because Ethereum, again, is focused on that functionality. But Bitcoin has double the market cap. And so there's this massive blue ocean of potential for developers to come in and build what they want on it in this very untapped new market. And again, there's a trade-off there. That means that the tooling's going to be less mature. You're going to have to be blazing a little bit of your own trail for a lot of this stuff. But for me, I like that part of development. I like the part where I have to get in, explore things, and there's a good balance here because the ecosystem's not, for some of these L2s like Stacks, for example, it's not so new that the tooling isn't there and the community isn't there and you're having to go in blind. It's been around long enough that we have some good tooling in the Stacks ecosystem. We have a great community, but it's small enough that one, there's a lot of opportunity to build things that don't exist. You can go into the Ethereum ecosystem and look at all these DeFi apps and pick some of the ones that you think have promise. And there's a decent chance they don't exist in the Bitcoin ecosystem yet. So then you can go build them. But at the same time, it's small enough that you can go into like the code for the Stacks chain itself, or you can go into the code itself for the main wallets and you can interact directly with the developers. You can understand exactly what's going on. You can wrap your head around it. So I like the balance there. And then the third reason for me personally is there's a lot of hype in the Web3 and cryptocurrency world. It turns a lot of developers off, very understandably. One of the things that's always drawn me to Bitcoin is that it's actually being used right now around the world to help people that are in terrible financial situations, whether that's an oppressive government, hyperinflation, whatever. Bitcoin's being used right now in those situations, which is really the ultimate promise of cryptocurrencies. It's supposed to open up the financial world to people. And Bitcoin's actually doing that right now in ways that are making a real difference in people's lives. And so for me, the exciting thing for me is, in my opinion, the money is only the first half of the battle to kind of bring this like financial freedom to the entire world. The second half of it is we need to build an economy and a financial system on top of this. I actually think that finance is very important for the growth of an economy, but that needs to be done right. If we have this decentralized money, but we're placing the control of the financial system and the economy still in centralized institutions, we kind of missed the mark on that. And so for me, the exciting part about being a developer in the Bitcoin ecosystem is we have the opportunity to kind of start at the very beginning and build up a new financial infrastructure, but one that's based on the same principles of transparency, openness, decentralization that Bitcoin itself is built on. So that's sort of like the higher level, like philosophical reason why I am really excited to be building on Bitcoin.
I love it. And Kenny, where should a developer go to get started when it comes to building on Bitcoin? Is there a set of resources? Where would you direct them if they want to get started and go 1, 2, 3 into building a Bitcoin application?
Yeah, so I'm a little biased on this resource because I'm the one that made it, but I made this free course called the Bitcoin Primer, and that's at bitcoinprimer.dev. But the reason I made it is because I actually had a hard time finding the answer to the question you just asked. And so what my goal was with this was I'm going to go find the resources that do exist. I'm going to kind of gather the basics of building on Bitcoin all in one place and then provide pointers for people to go out and go super in depth on whatever topic they want. So what the Bitcoin Primer is designed to do is to give sort of a holistic high level introduction to building on Bitcoin in general, and then provide different pathways depending on what people are interested in. So we talk about the things we went through here, like why build on Bitcoin, the basics of addresses, transaction scripting. The second half of it is more stacks focused. So we get into the Bitcoin L2 stuff of, okay, we've got Bitcoin. Now, how do we expand its functionality to smart contracts? But it doesn't overwhelm you with like crazy in-depth knowledge. It provides resources for what you want to do. But that's the number one place that I would recommend people go. A couple other resources that are great. Mastering Bitcoin is a book by Andreas Antonopoulos. It's really good. LearnMeABitcoin.com is one place that I went to, especially for like good illustrated explanations of how like different transactions and scripting types work. And then this is a paid resource, but Lisa, I think I forget how to pronounce her last name. I think it's Nagut or Nigut, but she works at Liquid, I think. Blockstream, and she has this company called Base 58, which is Bitcoin education, and she has a Udemy course called Bitcoin Transactions, and that's been really helpful for me as well.
Perfect. Well, thank you very much, Kenny. And a quick shout out, where can everyone find you, connect with you online to learn more, and also engage in some of their questions around developing on Bitcoin, but also to take part in your courses as well?
Yeah, Twitter's really good. So I'm Ken the Rogers on Twitter. And then if you go to bitcoinprimer.dev and sign up for that, you'll actually get an email where I'm CC'd on it. That's my personal email address, so you can reply to that. And then Discord, I'm kennyrogers.btc on Discord. So those are kind of the three main places I'd send people.
Right on. Well, Kenny, thank you very much. I greatly appreciate the time today talking about building on Bitcoin. Everyone, make sure to check out the comments below. We'll have all the resources that Kenny mentioned today down there for you to click and to engage with as well. I'm your host, Kyle Ellicott. Until next time, everyone, take care.